Hello everyone, welcome back. Picking up from where we left off yesterday, so trying to figure out the best way to write state machines in Zig. Trying really hard to encode it in the type system. So today we're kind of going to explore that more and try to write some comp time to generate some safer transitions between types. For example, only being able to transition from certain states to a select number of other states so that you are prevented from doing something stupid. For example, jumping from straight from setup to done processing or setup to timed out, or this is a pretty simple example, but in the long run, I'm mainly looking to state machines to figure out something for handling connections where the transitions are a lot more transparent and you need to get them right. So this is what we had last time, simple state with a couple steps, and then transition basically just with asserts that if you try to transition to an invalid one, you'll panic. And we rewrote the tick function in the main loop to make use of this. I think it ended up being better code instead of just like a while true loop. We use Zig's labeled switch to just basically have the same functionality as while true, but you tell it exactly where to go. So like after setup, we either go to, I guess, done processing or processing. And this is the compiler is actually very smart about this, and it will give hints for branch prediction, so it's actually faster than doing a while true loop, as well as adding some nice semantics. So that's always beneficial. All right, so I think what I want to do is just come out here and just make a fsm.zig, which is finite state machine.zig, and we're going to do some messing around here and see. There's a couple canonical examples for state machines. A lot of people use like ATMs or traffic lights. I think I'm gonna mess around with the traffic light example because it's a little simpler. So grab this. Don't need it right away, but probably will need it. So we can just say we have a and then right is just red, yellow, green. Also, if I spell it right. Yeah, so we just have 3 states, right? Maybe this is backwards. Green, yellow, red. There we go. Although if you can top, red, yellow, and green. I like to think of it as this way, right? So green goes to yellow, yellow goes to red, red goes to green, and any other state transitions between those are invalid. You can't go from green straight to red or from red to yellow. So how do we actually enforce that? Coming from Rust, I'd encode this in the actual types. I forget the exact words it's called, but you basically can have a type level, like a generic parameter in your struct that can indicate the type. It's called type state. That's what it's called. So probably looking to do something similar here, although we don't have the same level of generics. So we'll have to look different, but we want to encode it somehow. So my first kind of, I guess we can go 2 ways. We can go comp time and generate asserts, which I'm not a huge fan of, because I want it to just not be available as a option to go to the different transitions. I don't know if we can do that with Zig. That's what I'm going to try to get to. So I want to not just jump straight to comp time and, generating this based off of, some input. Instead, I think I want to look at like each of these being structs that have 0 size. So like we do const struct. This is really similar to what you do for the typeset pattern. That, and then we do a union like this, and this is going to be although that's ambiguous, so I'm sure we'll have to rename that in a second. And I'm just gonna go over here and just jump to our main file so we can experiment some. Just get rid of what's in here for right now. That, and that should let us grab build. We'll probably get errors out. Maybe because it's not used. Or maybe that's fine what we've done. I would have expected this to be ambiguous. But we'll see. So let's just say say we want to have a green forget the struct initialization format. Maybe it's just that. Yeah, there we go. That's actually cool. We'll see. We want to make these all public, obviously. Cool. So green. Awesome. It's green. So now if we want to this, and we just want to say that green equals G. Just because I'm gonna get tired of typing out traffic light, just shorten that to TL. Do that. Cool. We have a green traffic light. Something I am curious of is what is the size of this? I'm probably just access the type, not the instance. Yeah. Cool. So size of 1. So that's 1 byte. So which is a little interesting to me that it needs a byte. I'm assuming because under the hood enums are numbers, and the smallest it goes down to is 1. So that would be my guess. I could be wrong there. Yeah, that's not terrible to have 1 byte for the storage of this. You know, I'd love if it was 0, because it's really encoding stuff just for the compiler to figure out. But I don't think it's smart enough to get rid of it completely. Maybe it is. We'd have to go look at some assembly afterwards to really dig into that, and maybe that's next time, because I don't really have a good grasp of assembly, and it might be fun to figure that out. Cool. So basically what we want is, let me just get this back to like that. Sure I didn't mess anything up. I did mess something up. Oh, duh. So just still the size of. Cool. So basically we want to say, be able to say like tail.transition, and then take like an option here, like do we want to say it can transition to yellow, or do we not even let it know about that and just since there's no other option, right? It can only go to yellow, so we shouldn't have to provide it here. So how do we do that? So basically we want on each of these functions just to have a, which will take self, which is going to be a instance of green, and it's going to return something with traffic lights, but the problem is that just from the type signature, we know that we don't want it to return traffic lights, right? Because it can be any one of the options. We actually want this to return a yellow. Which is slightly odd. And then how do we get that back to from the transition? We need to get it back to the traffic light, because you'll have things that just operate like on all traffic lights, and it'll, like, as it's looping through, it'll call transition, right? So we want to do like, we'll just call it tick, because that's what I've been doing. And this is going to take traffic lights like that, and it's just going to do void. And it's going to do something to itself, right? It's going to keep iterating through these. So we're just going to say like, what is it? No, it's in thread now. Dot sleep. Second. No, we just want to do like that. We're going to sleep for a second, and then we're going to sorry, so switch on self, right? And if it's green, we want the message to be is green, like that. I can't spell const today, apparently. Like that. So we have that, and we're just going to be Yeah, so we're gonna do that. We're going to sleep for a second, and then we're going to do dot transition, which will be something. Don't know what it'll be yet. So yeah, it has. This is where we get into like the generics for Zig2, because we want to basically ensure every instance of these structs has a transition function on it. So I mean, we don't have to go that far yet. We could do we probably don't even want to make this public. Yeah, maybe we do. It doesn't matter yet. So, slides, fade. We're going to switch again. Self. It's not giving me the completion here. I'm going to do self.green.transition, which we will need. What's the self here? That's a little bit weird. How would I represent that? Because we're basically wanting it from here. Let me see if that works. Maybe it's just autocomplete being weird. Like that. Assuming we'll get a bunch of errors here. No. Because we're not actually calling any of these functions, it's not doing anything. So let's come back over here and just do tl.tick. Now we should get some errors. There we go. First off, we need to make this bar. Okay, so no field, remember name transition in yellow. Yeah, that makes sense because we haven't done this. Like that. Okay. And then now we're just gonna, in each of those, just do like that. Why is that unreachable? Let's see what the actual compiler says. Code, control flows directed here. Okay, whatever. Just gonna get rid of those. Okay. Incompatible types on 21. Yeah, so how do we do this? Do we do a green? Like, that's weird. Function expected. Okay, that's weird. Get back to this and see what messages. Incompatible types. Have. Alright, DJ. Have what? Okay, so it doesn't like the actual transitions. So I think all the branches are implicitly returning something different. So I mean, if we just, I mean, that should be fine, right? I'm not setting this to a value. It's just calling a function. Let's just do this right now. Most fantasy machine implementations I've seen implement a state-to-state definition and a trigger event. Please make sure I understand what you're saying. What form does the state definition take? Like, are you saying there's literally a function that takes in an event and then decides which state to return? Gotcha. Yeah, I've definitely seen them that way. And there's two different variations. There's the you need to transition states at runtime, and then there's the transitioning states is controlled programmatically, like in the code, and you're wanting to prevent people from like writing code that'll transition to a bad state. And that's more what I'm trying to do. Maybe they overlap a lot, but basically what I'm envisioning, right, is you have an object with like a state field in it, which has the enums in it, and that object is like doing a tick function. So like it's processing some data and then checking to see what state it's going to be, processing some data, and based on that state, it knows how to process the next data or the data it's currently on. But it's type safer in a manner that it encodes in like the types what you're trying to do, but still has that periodic event, or like in my mind I'm seeing it as like a tick that every 10 milliseconds or whatever you're ticking, processing, and potentially moving to a new state. So in reality, like green would go back to green if it's not ready, or then it would go to yellow, but it could never go to red. And basically I want it to encode in the type system that like if you're at green, you can never get it to compile with sending it straight to red. I mean, if we're just looking at, I don't know if you saw what I had yesterday, DJ, but I have like a setup processing, and it's basically what you're describing, where you have here's a state, you do some setup, and then you continue, and then you do some more work, and then maybe it's not what you're describing. You do some more work, then it transitions to the next state. There's no really external event, at least here, triggering it. Although maybe that's not fair. There is one. One is a timed out. So there's an external event, like we check, like, hey, did it time out? And if so, move to the timeout state. But at this level, it's controlling its own state and not reacting to external inputs. But that will definitely come later for like the connections. Oh, whole bunch of rambling. I don't know if any of it made sense. Yeah, so I think what we were running into before is every bit of the since we were implicitly returning a value here, like because switch statements can be expressions and values. Each of the branches have to implicitly return the same type, and since we weren't doing that, it couldn't happen. Yeah, I'm just gonna do. Actually, I'll do this. It's easier. Is it smart enough to catch this? Yeah, the Zig generics are interesting. I like them. I mean, it makes you really need to understand what you're trying to do to make it work. You know, like implementing your own vtables so you can have basically traits or type classes, whatever you call them. Cool. And then we panic, which is what we want. So the light is green. This isn't what we want to do, but that's what we need to do eventually. And then we just want to return. Just do like yellow. Okay, now these are actually implemented. You should see it just run and continue, say the light is green. Oh, I'm only ticking once, so. Yeah, light is green, light is green. We know it's green. So then over here we need to do something that's value, so we just want to say this is, yeah, I'm just doing the traffic light just to figure it out, right? Because so yesterday, I'll show you. I did it in our IO loop. I don't know, Dustin, if you're around for talking about that, but it was just like a while true loop where it loops through all the continuations, and then if they were completed, you know, called the actual continuation to complete it. Otherwise, would move on, and then it'd be done with the tick after it did all that. If you remember last week, we added the timeout to it, so then basically the timeout set for, I forget what I actually set it to, 1 second, which I actually need to update that to not be 1 second because that's way too slow. But now we have a timeout, so we can just say in forever loop, not limit it, do these things. And I transitioned from just this big block in a while true loop to actually having states, because there's discrete parts of the process of handling the continuations that I wanted to handle. So first, we do the setup, and we say the node we're looking at is the first one. If that node is null, it means we have nothing to process. We just move to done processing. Otherwise, we move to transitioning. And for those of you who haven't seen this, this is Zig's labeled switch statements. So it's basically like a while true loop, where instead of saying continue, you say, and in the while true loop, you say continue here. And then here's your block label S, which is also here. And then you give it the new value. So you can, this is a function that returns value. So we're moving to the processing state here. The benefit of this over just a while true loop is I think it's much clearer what is happening, and you don't have a bunch of nested continues everywhere. I mean, you do have some in different places, but they go to discrete places. And then the other benefit is the compiler actually uses this to do branch hinting for the CPU. So it's actually more performant than a while true loop, because a while true loop basically has to do a goto and without the right context. And so it can throw branch predictions off. Whereas this, the compiler can say, okay, cool, this is returning the processing state. I don't need to jump back up to the top of the while true. I can jump directly to this code. Yes, continuations are the events that the loop is consuming. Yes. So it's, and that's based off of the concept of like how IO is handled by the operating system. Like they're basically events under the hood, and that's basically an event bus is how it works. Hand wavy. So that's where the term event is coming from here. So an event in this case is something was added to the queue, or something has been handed back from the operating system as being done. Does that make sense? Here's the part I don't like, because right here I have to set self dot like this. So this defeats the whole purpose, so I don't like this, but I'll just get it working, then I will complain about it. So it's, oh no, we don't even do that. Okay, so it's asking in the field. So what we need to do here is actually I think what we need is another function in each of these. Like, we just need to say set self equals to this. In fact, we could just do self equals this. And then we don't need these. I'll show you here in a second. We're going to get that same error that they have to all be the same type, I think. Yeah. Yeah, we expected this, found yellow. So what we need in all these is it's just two traffic lights. It's going to take a self. Green, I don't want to do a pointer here, I don't think, because the internal thing doesn't take a pointer. And then this is going to return to traffic lights. That is just going to be traffic lights dot green. Sorry. And then dot green equals self, like that. We're going to do that in all three of these, and I think you can see where having some comp time functions to build all this out will be very helpful. But we'll get to that in a second. Not in a second, but maybe tomorrow. And then we have to do this for yellow. Then we have two options. We can say self.green transition, and then from here go 2 traffic lights like this. See if that works. That's not copying. Like that. Don't love that either. It's very verbose, but let's see if it will build. No. That we discarded, so. Where do we discard? Sorry. Oh, sorry, I need to. Pick the type, found that. So let's just not deal with pointers for a second. Let's just get rid of these real quick. These are small enough things that pointers to them, the pointers take up more space than the actual thing. Cannot assign to a constant. Oh, duh, because so this is going to be. Okay, so it's a. Should I do that? It's self.star here. There we go. Most prong required. 21. Oh, duh, because this we don't want transition on that, not the. Otherwise, that's switching on the pointer, which is a U64. Cool. This is red, green, yellow, red, green, yellow. So how can we make this better? I think one thing we could do to make it better is to make transition return just the traffic light. I don't know if I like that as much, but you can do like yellow dot. This and then do white dot 2 traffic lights like that. You can't just do the 2 traffic lights here, by the way. That's why I didn't do it there, which is annoying. But again, then you're losing like the type safety here, because in theory, if you just call a green dot transition, you would, on the output, you'd have to do a switch statement. And I don't really want to do that. I want to make it very clear that transition from green returns a yellow. The problem is, how do you encode that? What happened, or how can you encode multiples valid state transitions, because this only works for one. Do you have to do an enum valid states, which then gets really weird. Okay, should they all be different types then? I've never quite understood the benefit of enum state machines over state machines with different struct types. Yeah, that's kind of what I'm getting at. Like, in Rust, I would just use a type state, and it, while verbose, it just kind of works and provides me exactly what I want for the safety. And yeah, I lean more and more in agreement with what you're saying, which is don't do an enum, do just different structs that return different values for what they can transition to. Which is kind of where I lean. The one thing that's nice on, and maybe this is just I'm reaching for the wrong abstraction, the enums lets you handle everything with exhaustive checks. And you can just say, here's something that is state, and then do something with it, and then you can be exhaustive to make sure you handle everything. But I don't know if that's actually necessary with if you just use structs and transition from struct to struct. The other downside is memory overhead of that. I mean, you're copying a lot of values all around, which is not something like, cool, another bot user to ban. Gotta love doing that. So for example, like in my IO loop, I'm not at the moment storing a state thing here at the top level, but I could definitely see where I just store a single state enum that just has these. So like you're basically only storing 1 byte because you're not exceeding 1 byte's worth of options, and these are just integers under the hood. Whereas if you use the struct method, you would be basically copying a bunch of data around the stack. Like it's not a big deal. Like maybe it's premature optimization for the sizes that we're talking about, but it's something I want to be cognizant of. I want to basically eliminate as much of that as I can. What is the size of green here? Messed up something over here apparently. Oh, sorry. This needs... No, that's right. What did I do here? Oh, that's why. Let's be yellow here. Okay, so green is actually 0 sized. So I mean, if you do it that way and you don't have any data on it, it is smart enough just to be 0 sized. Right. You can maybe get away with separate types than an enum with an option for each type. That way you get the type safety for state transitions while being able to handle any valid state when needed. I don't know if SIG supports union types, but that would also cover the union benefits again. Yeah, it doesn't support union types, unfortunately. And that's what you're describing is kind of what I'm doing here, right? I mean, it's you have green, which is green, yellow, which is yellow, red, which is red. So I have like the structs, and the structs, transition to each other, but then you just have the green. But so I mean, I think I'm leaning towards doing what you're saying. But I don't know how to encode multiple options in this with the overall enum. It's like, right, we want let's say green can stay green. Like that's a valid state transition, right? It can just stay green. So this returns green, right? Let's say self here. Done. All right. So how do you know at this level? At the level of like, I know I have some state. I want it just to advance to the next state. How do you handle that? And so to do that, I think you have to put some data. You have to either store some data in the type, or I see what you're saying. That's what union types would help with. Something like type. Yeah. So like, exactly. You could do. Transitions, which would then just be a union, enum, and it'd just be green, which would be green, and then yellow, which would be yellow. Which, yeah, I mean, that's definitely an option. Let's see what that would look like. Just for fun. That is, you know, how you would write this, I think. And then transition would return, you know, a valid green transition. Yeah, you missed pair programming. I mean, I liked it when we did it a lot. It got old doing it, you know, 8 hours a day, but it was actually somewhat fun, depending on who you're paired with. So then I think you need the same, like the same two traffic lights function inside of your valid green transition here. Now this is self now is a valid green. It's getting very verbose here, which I don't like, but it returns traffic lights. And then you have to switch on, you know, yourself. So it'd just be green, and then you'd return a. How do we get this down here? Traffic lights. Traffic lights, and then you do green equals green. You know, and I'm not too concerned with boilerplate here, because I mean, I think I can throw these into some comp time functions and generate most of this. Like I said, maybe that's what we do tomorrow, but I want to kind of nail this down first. So in theory, even better, what we can do is, if it's green, we can do green dot green dot two traffic lights, and then we don't even need to encode that logic twice. Like that. And then in theory, right, this green dot transition, there's that. So now we need to return, say, also, I think this is the way I would ultimately want to handle errors too, when there are common error types. Find each error type that could ever be returned and use enums by function-specific error types, similar to what we do in dig quirks, though we never quite got them in the right place. Yeah, I agree. Yeah, because I mean, what you end up like, I haven't looked at our Rust code base in a while for this, But I really hate the giant ball of mud errors that just are everything and you don't actually need to handle 90% of them. So no, I definitely agree with that. Let me think for a second. How do I get a random number? I have a test thing that does random here. There we go. Let's do that. I know this is a bunch of boilerplate here, but I just want a random number. Next. I don't want to. It's just a U64, so I'm going to say like if rand modulo 2 equals 0, turn dot. Like that. Else, I don't mean else here, but like that. There. So there's a 50-50 chance that it just returns itself. Did I do all that right? Light is green, light is green, light is green. Apparently we only do even numbers. Oh, it's because the seed is always the same, so it's always getting the first one. I'm just gonna throw this up here. There we go. It was just setting the seed, and it's always just taking the first one with the same seed. So that's why. Cool. So it works. There we go. We have it encoded where it can have multiple options. And honestly, it wasn't that bad. Now, do I like it or not? Is the question. So it's definitely verbose. And does it help me achieve what I want to achieve? I think it does. Because it lets me initialize like this, like, right, this is the function I actually care about. I'll get rid of this. Right, and it lets me be extremely explicit. I can only return one of these, and I have to set it to either be green or yellow. But I think I like it. So then the next question becomes, can we reduce the boilerplate? Which I think we can, but I need to do some reading on some of the comp time stuff for building out an enum, because I don't know that off the top of my head. But I think we can. And I think that would help a lot. And so what this is all leading towards, like, I was messing around with this yesterday, right? I didn't really need to rewrite this this tick function in here with the state. Like this state is kind of arbitrary. It's right. Basically, while we wait for the timeout, continually look at the continuation, see if there we can do. If not, do an IO tick to advance IO, and then do it over again. Like that's not super crazy. Like it's simple enough, but I still think this makes processing that easier, like mentally holding it in your mind easier. But what I really need this for is accepting connections, because how it works, like let me just go back to our main function, look at some of my commented out code. Right, so we have an address and we resolve it, we listen to it, we get a file descriptor, and then we call loop.accept. The thing is, like, you can only accept one connection at a time, because that's you're accepting something on that file descriptor, and then from that you get a new file descriptor, which is what you're actually using to communicate with that the client. But we always need to have this one continuation around that is there for accepting connections, and we need to manage the state of that. Is like, is it in the middle of handing off a connection to a different process? Is it not being used? What have you? And so we need to really make the state management very clear there. And then just for connections in general, I want to pre-allocate all the connections so that you never run into any issues. Like, I don't know if, Dustin, if you've noticed some of our recent issues with dedicated, where we run out of connections to Postgres, to the RDS instance, and it just like hangs. And that's because Postgres under the hood is doing the same thing, right? You have a finite number of connections you can open to it. It's allocating them, and that way you can't basically crash because of having too many open connections. So we need to manage this pool of connections. So that's some state management. And then I also want to have one other connection available for just responding with too many open connections, because that's something that's been painful for us, is like when there are too many open connections, a lot of times it just hangs. It doesn't always return you an error code. And I want to make it more user-friendly than that. So that's where the actual like complexity around like where state management stuff comes in, that is where I want to manage. And then inside of each connection, right? So right now we're working on the Postgres wire protocol, and that is very much a finite state machine. Like you listen for a startup message, you send something back. You listen for another message, you do some processing, send it back. So I think getting this right is really important, is basically what I'm trying to say. So where to next? Yeah, I think I just need to do some reading on the docs for how to actually manipulate things. I know there's you can do, let me just back over here. Like say we wanted to look at like the type info of dot. Yeah, the sizes are super important to me, and it's probably premature optimization, but it's interesting enough to me that I want to think about it. So let me get rid of this launcher. Right, values of this union field. Does it not like just printing this? That's surprising. Yeah, so how do you do type info? Do I have to do like dot green? No, that doesn't work either. So how do I inspect this? It's not. From int, enum, error name. Like this should be an error since this was just going to be in the same order. So why can't I do type info here? But index value is runtime. Do I have to do? Yeah, I thought that didn't work either. Yeah. Oh, I think it's because I'm trying to print it at runtime, which obviously can't happen. Duh. So how did I do this in the past? I think there's a compile log. Yeah. Okay, cool. Yeah. So there we go. So found compile log. It doesn't actually let you build it with logs in it. So it's union tag type has type info. Union tag type fields. That doesn't help me very much at all. Dot. Does it have? Access of union field union. Well, union is not active. Okay, something that I think makes sense. Let me just see if I can figure this out real quick. Maybe I have to do. But because it's a union. Dot fields. Okay, so that is progress. Now we have it is the union field type, and here's our names. Green has a type, has an alignment. Yellow alignment equals 1. Yeah, okay. Just string. Okay, so that's how. So we can get our fields out that way. How can we? Okay, so there's center.meta dot. Let's see what's available in here. So this is like the metaprogramming stuff. Field enum returns an enum with a variant named after each field of T. Interesting. So you can make a, let's see, just a non-state, let's say red. Just to differentiate it here. So we have this. All this DUX stuff afterwards, so I'm sure that this is all comp time. And then I want to do like that. Do like that. Type does not support radiation. Okay, dang it. Too hopeful. So I don't know how that function works. But it sounds promising. This field union returns union with a variant named after each field of T. Okay, good to know that exists. Don't know what it does. Sentinel. For a given anonymous list of types, return a tuple type with those fields. Interesting. Returns the active tag of a tagged union. I'm sorry, I'm just kind of browsing through what's available in here, which I know isn't the most interesting thing. Fields. Returns the fields. Has, oh cool, you can say has FN. Has function, has method. Is error. Whether error union contains an error. Tags. Given an anywhere error, set type returns a pointer to an array containing all tags for that enumerator error set. Okay. Interesting. Okay, so I think I just need to do some reading around this and figure it out. Get back to traffic light working. Oh, CORM. ORMs are so great, aren't they? That works. Just to get back to where we were at the end of yesterday's stream. So I wanted to do one other thing. All right, cool. So this, you can see the timeouts are actually working now, where they weren't before. And it's taking a second, but I wanted, as I mentioned in our loop, to put this to be 10 milliseconds for the timeout, not 1 second. 1 second's way too slow. There we go. Yeah, so our IO loop is obviously taking 0 seconds, 0 milliseconds. So, you know, same thing, except we're making the IO loop work a lot harder. Under normal circumstances, right, it'd be doing a bunch of processing, but right now it's basically just busy waiting. I want to main. Let's just do this. Nano timestamp. We can see actually how long it took. Oh, that's the wrong place. Where is it? Oh, it's here. So this is the one nano timestamp here, and then timestamp there. All right, now we can actually see how good it is at keeping up. All right, so is that right? So it's taking like 15. Sorry, 1 sec. Am I even doing this right? How many nanoseconds are in a millisecond? Is it 100? We'll just do a millisecond. It's 10. There. No, 100% that it will be. Oh, it's 1,000. Okay, yeah, I was making it take way too fast. Math hard. And then I think we can just do, obviously we can just do milliseconds here too. Cool, so it's consistently taking 10 milliseconds. That is what I wanted to see. There's some drift, probably just due to logging, you know, for right here. But otherwise it's working fine. And this is more of the level that I wanted, so cool. All right, I'll probably call it there. I think this is a good stopping point since I have to go read more about comp time for actually building out like these structs and enums by hand. Any other questions or anything? If not, I'll head out for the night and hopefully your CRM issues go away and it's all smooth. Might as well commit my stuff too so I don't lose it. Yeah, always welcome to add state stuff into the Granite code. Love it. I don't know if you've seen the Rust type states, state type or type state, either one stuff before. I think we've talked about before, but in Rust you can do even cooler things. So yeah, if you find a use for it, let me know because I've been looking for use for it in our code base forever. So, all right. Thank you everyone for tuning in, and I'll be back tomorrow. Yep, that's the one.